welcome to the first Tech Talk of this summer. I know that some of you are undergoing quite a lot of heat right now, so it's really nice that you've joined us for this Tech Talk today on Friday. And as always, I would like to have a small introduction on the plan for today, and then I will just hand over in 1 or 2 minutes to the presenters of today's Tech Talk. As always, know that the session is being recorded, and we will upload the Tech Talk as always to the YouTube channel afterwards if you want to send it to someone who cannot be here today, who's missing it. So as always, we have a brief agenda. We will start with today's Tech Talk, followed by a discussion afterwards. And then there we will share a few news and events of the ALASCA Association, and you can also share any of the events and news that you might have from your companies or organizations. So feel free to share that at the end. So today we have a Tech Talk with a very nice title, To Standards Infinity and Beyond, a tale about Yaook and building SCS-compliant clouds. So we will learn a little bit more about a pilot project to build an SCS-compliant cloud using Yaook. And we have 2 great speakers for that today. We have Felix from the SCS project and the OSBA Association. So he's a product owner of the ES, the SCS project, and member of the board at the Open Source Business Alliance. You can see here a couple of his hobbies or his the areas where he works: cyclist, Unix, BSD, Linux. I have to say I had to search for some of these things yesterday, like the foo bar was a mysterious thing for me. So yeah, also expert in infrastructure, monitoring, outdoor, and very active in the Sovereign Cloud Stack project. And then we have Jonas from Cloud&Heat Technologies, who's one of the minds behind Yaook, co-founder of the tool in 2020, and has been working as DevOps engineer and now as team lead in cloud infrastructure development in Cloud&Heat. So yeah, 2 great speakers for this topic today. And I will not take the microphone any longer. So Felix, you can start sharing as soon as I stop, and then you can start with your Tech Talk.
Hi, thanks for the introduction. And you should see my slides. I now just have to rearrange. But you see the slides and the intro slides?
We see the slides. Yep.
Perfect. Yes, thanks for inviting us to actually give this talk. I will, since I'm not sure who, well, SCS has been around for quite a while now, but I nevertheless will give an introduction to the SCS project before we dive deeper into the specifics about Yaook and building SCS-compliant clouds. SCS, and we came up with the slogan, one platform, standardized, built and operated by many, 2.5 years ago. The project has been running now for almost 3.5 years, and it was initially the idea came up that we wanted to build a cloud stack, and it was initially funded by there was an initial funding by the Sprint, the Bundesagentur für Sprunginnovation, where we initially evaluated the proposition of a sovereign cloud stack. And once that was successfully done, and it was also great that we actually had the chance to evaluate that, we then approached the Ministry for Economic Affairs and Climate Action, BMWK, to get a funding, and in order to actually do the project. Initially, it was an idea by Kurt Garloff, Christian Behrendt, Oliver Maus, and Peter Ganten, and a few others. And then we started onto the journey in 2021 to actually build and standardize cloud infrastructure. The project works in a way that we have the funding money, and we work with various tender packages. So all the work that we fund is done through tenders, and with the tenders, we were actually able to do a lot in the last 3 years and get a lot of things done. We're now in the final phase of the project, so the project is running until end of September this year, and because of that, we've been very active in actually finding ways to sustain the project further than September, and I will, in the end, also elaborate a bit on that. So what does the sovereign cloud stack actually do? We want to make sure to have certifiable standards, to build a reference implementation, and to make sure that communities work together, which we call open operations. And we do that in a complete open source way. And we actually have our definition of digital sovereignty and certification. And digital sovereignty is a term that has been used or is actually already a buzzword in the last years, or has become a buzzword. We actually define 4 levels of. I'm actually surprised my LibreOffice apparently thinks it wants to skip ahead of the slides, so I'm sorry for that if I have to jump back. So we have 4 levels of digital sovereignty. The bottom one, where we start, is compliance with regulation, which is often referred to as data sovereignty and regulation within GDPR. And then we say the second level of digital sovereignty is the choice between many operators, and also the possibility to do insourcing. One of the other terms that has been used in the industry for that is cloud repatriation, so that you actually you start out in a public cloud, and over a few years you actually discover that it would make much more sense for you to actually have the cloud on-prem in-house for various reasons. Maybe because your product has grown so much that you actually can sustain half a rack of full rack, and the public cloud resources becoming so expensive, or maybe because the public cloud you're using has changed their business model or increased their pricing so much that you actually see more reasons to have it on-prem, or because you have new customers that require different regulation. And so basically the option to be able to insource your cloud is the second level. Then technology transparency and the ability to contribute and shape, and being able to actually add stuff to the product as well. Something that is very natural for us open source people. And last but not least, the fourth level is operational transparency and accessible knowledge. And I already mentioned we work with the certifiable standards, the open source reference implementation, and operational knowledge. And these are the 3 core pillars and deliverables of the sovereign cloud stack. And certifiable standards are important because if you have certifiable standards, it can actually be used in tenders, and people that write tenders can actually say, hey, we want to have offerings that are built in an ISO certified data center or BSI C5 certified data center and fulfill these other standards. And for that, certifiable standards are important, and also to become comparable. And with certifiable standards for the consumer and the user, it becomes clear what they can expect from an environment. And today I will focus on the certifiable standards because as you can also see then from the stuff that Jonas will show, is that they adopted the certifiable standards in Yaook, which is actually what I think is a great adoption, because we now basically have other solutions outside of the second pillar of the SCS project, the modular open source reference implementation. So aside from the standards, we actually build an open source reference implementation, which is built on top of OSISM, the open source infrastructure manager, which is one of the many ways to actually deploy an OpenStack-based clouds. And the OSISM tool tool set is built in a way that if you roll out a cloud, you can easily adopt the SCS standards with it. So that's one way you can actually have an environment that is SCS compliant. And it was important for us to actually not only do standards, but also ship a reference implementation for all those people and entities and companies that do not have a cloud stack present yet, or that want to actually build up a new cloud stack. But it was always clear that not everybody starts greenfield. So the certifiable standards are actually made in a way that they're easily adoptable by other clouds as well. So you do not have to start greenfield in order to have an SCS compliant environment. And the third pillar is accessible operational knowledge. Some of you maybe already encountered the open operations meetup. So we basically make sure that within our community, we do the open operations meetups, but also have other formats where we make sure that companies and people, and actually companies are made out of people, so that they can easily work together. And if we look at the landscape in Europe and all the CSPs we have here, a lot of them basically use similar technologies, similar approaches, and we think it makes much more sense to actually work together, because the cake that is available is so large that we do not have to fight for little crumbs of that. And the SCS standardization, we treat it like basically like open source development. So we work together within the communities. We call it a community-driven process. So it's important for the standards to not basically be made within a group that is closed, but instead basically have an open dialogue where the standards are derived within. And the community-driven process is open to everyone to join. We actually have a public calendar where all the meetings in SCS are available, and people can just come by, because standards that are basically made in a closed group will likely not fulfill all the stakeholders' needs. So with that, we actually make sure that all the stakeholders are involved in the standardization process, because we want to make sure that the standards we come up with are actually standards that help the customers, but also the operators. I just, in an email the other day, where we were elaborating on the adoption of certain standards, I used the term operator experience, because I think it's also important that the standards offer a good operator experience and adoption, because then cloud CSPs are actually likely to adopt these standards, because it also makes their life easier. So the process that we actually have to come up with a standard is a proposal, which is done in a GitHub PR. Then we go to a draft. So the initial document is a draft, and from there we go towards stable or rejected. And the period between the draft and the stable is actually the period where a lot of the core work on the standard is done. And I see in the participants of today quite a few that actually work on that process. So it's involves, so while it's only a small arrow in the diagram, it's actually a large discussion where we actually make sure that each and every one is heard, and that we actually come up with something that is then stabilized. It also makes a lot of sense. The standardization process is done in the special interest group standardization and certification, which is led by Matthias Büchse, and it's part of our tender package 10.3, where basically we make sure that all the standardization efforts and certification is driven forward. As the outcome of that is, and you can see that on our page docs.scs.community, are the standards in a nicely laid out way. And for explanation, we have in the standards in several tracks. So we have an ERS track, we have the Kubernetes as a service track, we have the Ops and EAM track, and for reference, because we are also going to look at the Yaook implementation, I want to briefly look at the EIS track and what we actually do there. So we want to make sure that if you move infrastructure from one cloud to the other, that is done in the most easy way possible. And if it's easy, if the assumptions that can be made about the cloud are the same. So the infrastructure as code tooling should work the same across SCS compliant infrastructure. And so topics that we initially very early on started with making the flavor naming the same, which is as all and everyone who has an OpenStack cloud knows, a fairly big pain, and it was probably not the easiest topic that we started with. Through the standardization of flavor names, we actually then discovered that there's more work to be done in the OpenStack world. For example, discoverability. So we basically noticed, okay, a standard set of flavor names is nice, but it would be much nicer if I could actually discover these kind of things. So we're actually now also looking into making discoverability work. We then also standardized images, metadata for the images, how metadata is annotated, things like entropy, so that if you spawn a VM, that you can make certain assumptions about the entropy that is available there. And each and every thing that we standardize and we write a standard for is then actually also written down in the test. And it's written down in tests so that we can actually then test for standard conformity and transparency. So basically, we are currently working, or the colleagues working in the tender package 10.3 are working on a conformance monitor that basically runs the conformance test in certain set of intervals, and will actually the result are the badges that are printed on the website, which cloud actually fulfills which standards. And so right now it's a set of GitHub actions, and we do the same stuff in Zool, and we're working towards actually having a conformance monitor that is then completely living in, I think, Zool. Yes, we have already quite a few environments that fulfill the SCS standards, and that's actually really nice, and something that has happened in the last 4 to 5 months is that we do not only have environments being SCS compliant that are built on the reference implementation, but also other environments that adopted the standards. So, for example, SYS11 adopted the SCS standards, and they did not build anything greenfield, but they actually implemented the standards in their already existing cloud environment. And there's also one environment built up by Cloud&Heat with Yaook that is basically, that is SCS compliant. And Jonas will now actually say something about the journey with Yaook and SCS compliance.
Yeah, thank you, Felix, for the first part. You can already go clickety-click. I will say a few words. So I will briefly talk about what Yaook is and what components it has, and then I will guide you through the process of how we set up the infrastructure there in Leipzig. And I want you to look at the places where making it SCS conformant is actually relevant, or where that plays a role, because I think this will serve as a nice example of how the standardization thing in an already existing system actually works. Right, so first of all, what components does it have? So if you don't know that yet, and you haven't been to my, I don't know if that was even me. Anyway, if you haven't been to any of the talks explaining Yaook, here's a brief reminder. So the basic principle of Yaook is that we install OpenStack on top of Kubernetes, which some consider insane, but we consider a really good idea. I will start from the right. So for that, we have written Kubernetes operators for all the OpenStack services, which provision these. An operator takes care of ensuring that a system in a Kubernetes cluster is running as it is intended to be running. And we want to actually make them work in a way that you don't have to be afraid when you do upgrades or changes. Fearless automation was the title of our first OpenInfra talk on that. And yeah, basically all the things which you might encounter in an OpenStack cluster as day 2 operations should be automated in a way which don't hurt you. Normally, we run this, and with we, I mean Cloud&Heat specifically. You don't have to. You can also use a different Kubernetes setup, but we run this on Yaook Kubernetes, which is basically lifecycle management for Kubernetes clusters, which provide almost everything you need to run Yaook Operator. Yaook Operator has some dependencies on the specific Kubernetes setup, which are then delivered with Yaook Kubernetes, but you can also install them manually if you want to. That, in the context of a bare metal setup, uses an external asset management netbox to learn about its nodes in combination with the Yaook bare metal stack. The node there is important. Some of the Yaook bare metal stack is still work in progress. We are working on refining this, on smoothing out the rough edges. It's basically the start of that was a 2-week hackathon where someone wrote the initial component, and then it evolved from there. So it's not perfect yet, but it works good enough for something like Leipzig. It has an asset management tool, Netbox, for the various nodes in the deployment. It has an OpenStack Ironic, actually, in the underlay. We are kind of doing something similar to OOO there. And the heart of everything is the Yaook Metal Controller, which basically bridges Ironic and Netbox to allow you to deploy nodes with just a single click, basically. Click, please. Speaking of clicks. So brief run through the hardware. What does deployment look like? We have really beefy nodes there with 128 threads, I think, and a lot of RAM for compute. Those nodes are embedded in an infrastructure consisting of redundant firewalls, switches for data and management, which is separated for sensible security reasons. We have the Yaook management cluster, which in this setup consists of only one node. You can run the management plane on multiple nodes, but here we went with one node because that's not really critical to running the cluster. If it's down, you turn it back on and recover from backup or whatever. You have time for that generally. You don't need it for the day 2 operations normally. You have the controller nodes, in this case, 3 of them, which run Yaook Kubernetes. And in this case, because of space constraints and node constraints, we also run the OpenStack control plane on the same nodes which run the Kubernetes control plane. Not ideal, but works well enough. Then we have dedicated compute nodes. Of course, those don't run control plane nodes. And we have storage nodes, which are also dedicated, where we run a Ceph cluster used as a storage backend for the OpenStack. Next slide, please. And yeah, this is the installation procedure. And I would like to remind you, watch out for things where the SCS standard actually starts to play a role. So first steps, you set up your hardware. You need to ensure that the BIOS is set up consistently, virtualization is enabled. Otherwise, you won't have a lot of fun with OpenStack. Disable hardware rates. Please go back. Thank you. Disable hardware rates because those are annoying. Set up IPMI and so on. All this good stuff. Then you need to connect your network. You need to ensure that the VLANs and the ports are configured correctly to separate traffic where you need to separate it, and you allow it to join where you need to allow it to join. You deploy the firewalls or edge routers or whatever you have at the edge of your deployment. In our case, those are basically Linux machines. We use the router operating system Wios there, which is Debian based and has a nice CLI and allows for lots of configuration of good stuff you normally need like routing, port forwarding, DNS, NTP, and so on. Once those are configured, you can actually start with installing nodes. So you provision the management cluster. We call this YMC. In this case, just a single node, which is again a Kubernetes cluster where we run the Netbox, OpenStack, Keystone, and Ironic for the bare metal node management, small DNS and DHCP server, and the metal controller. Automation here is quite good, but not perfect yet. I mentioned the WIP part earlier. Then you have to put in all the details about your nodes into Netbox so that Netbox and the entire stack knows what's what. Like which hardware do you use, nodes configuring the network interfaces there mainly, the subnets you use, IP ranges, VLAN IDs so that those are matched, You need to define the domain name of your deployment, which is either publicly routable or at least resolvable within your stack, and more like that. So which node is a storage node, which is a controller node, that needs to be configured so that the automation knows what to deploy where. Click it, please. Then you go on and roll out your Kubernetes, including Rucksack, the storage cluster, which is really easy. You just switch the node from planned to active in Netbox, and then the metal controller notices that and triggers ironic to do stuff, and then Kubernetes rolls out and installs itself. It's really fun to watch that, actually, when you get to that point, just nodes flipping from available to deployed, and then you can actually see them in kubectl, really nice. Then you deploy the Yaook operators, configure the labels, deploy the Helm charts, and you go on deploying OpenStack. One manifest per OpenStack component with all the settings you need, network interconnectivity, domain names, and so on, certificates, you name it. And then in the final step, you make this SCS compliant by configuring the flavors and images and the networks and whatever else OpenStack needs, SCS needs. And that is just the last step. So all the other stuff doesn't really know or care that this will be an SCS compliant deployment. We only had to adapt like the last step we do when deploying an OpenStack cluster, which is what flavors to be deployed, what images, because that is the only part the user really sees. I know that some standards are in development, like with specific network requirements that you need to have IPv6, for instance. Then you need to plan a little bit ahead in the earlier steps, like set up your firewall so that it can work with IPv6. But most of the part, even with those standards considered, is just deploying an OpenStack and then configuring it to work with the SCS standards. And I think that really goes out as a good point for the SCS-IS standards, that you can actually make them work with an existing OpenStack distribution. Because when Yaook started, we had some idea that it might have to be SCS compliant at some point, but we didn't work toward that specifically. And then we could just still do it for this Leipzig deployment. And I think that's pretty nice, actually. And yeah, that would be my contribution to this shared talk. Handing it back to you, Felix.
Perfect. There is a really nice blog post by the colleagues from Cloud&Heat that I will put in the chat here about the costs of making an OpenStack cluster SCS compliant, which is probably some nice reading and also references a few of the standards. So I think that actually fits today's topic really well. And initially, I was introduced as the PO for the ERS reference implementation of the SCS. And you might wonder why I'm so happy that actually another implementation adopts the SCS standards, because one could think that Yaook is actually in competition to the SCS reference implementation. And I would just take a few moments to elaborate on that, because that actually so when I first heard that that this stack is going to be built up and using Yaook and SCS is made SCS compliant, I was very happy, because it shows that the SCS standards are actually adopted outside the own group of or peer group of people. So, and that actually shows that it gains traction and it becomes more relevant, because now people that actually want to use Yaook can easily also make sure that their environments are SCS compliant, because it has been proven, and things like the blog post actually show that it's done with very little effort, and that enables more and more people to actually have SCS compliant clouds. And I'm really thrilled about that. And also it's a bit basically also a matter of taste, whether people want to, or requirements, whether people want to run Yaook-based environments, or, for example, OSISM-based environments that OSISM, again, builds on top of Ansible, which is basically OpenStack in containers or in Docker environments. And so this just opens up the landscape of available solutions. So I'm very, very happy, and I'm very thrilled about the contribution from Cloud&Heat on that side. So I also good moment to say thanks for all the effort that Cloud&Heat puts into that, also outside of the tender package and not just as part of the tender package. And I think with that, we can actually dive into questions if there are any.
Thank you very much to both for the presentation. So now if you have any questions, just unmute yourself and ask the questions, or you can also paste them in the chat or raise your hand, whatever you prefer. Maybe a first question then from my side. When you say that it's not that's only a little effort to implement an SCS-compliant cluster, can you maybe quantify that? I mean, like, is it like 10% more than if you would just not implement the SCS standard, or is it exactly the same as if you would implement your own flavors, or so just that we have a reference of what little effort might mean in this context?
So actually, if I may.
Yeah, sure.
Actually, if we take that from the perspective of how we did things before SCS, it's less effort than not doing that at the current point of standardization, right? So with the main focus on images and flavors. Because there's automated tooling made by the SCS reference implementation, which we can just reuse because it just talks against the OpenStack API. And previously, we would actually do that by hand, which is obviously much more work intensive. So at this point, the standardization actually saved us work compared to how we did it in the past. That will, of course, change when more elaborate requirements like IPv6 support or whatever comes in. Then you will have to consider this from the start, and there will be more work to do. But it's hard to quantify, really, because we haven't done that yet.
I think for greenfield deployments, it's also very easy. It's a bit different if you have an existing cloud environment where you say you want to adopt the SCS standards, because then you actually have to make sure that it doesn't interfere with your existing stuff that you already have. So that's also what SUS 11 basically, when they adopted the SCS standards. Initially, they thought, for example, oh, we can either have our own flavors or the SCS flavor naming. But then basically, and that was a misunderstanding, because it's not either or, it's in addition to. So you can basically have the SCS flavors and all the other flavors. So that's not exclusive there. And then, for example, for the required images, you have to make sure that that doesn't collide with the images that you already have, or with your naming conventions, things like that. But if you start greenfield, it's actually very easy. And as also Jonas said, now looking forward, and that's also one of the, one could say, more interesting parts of the standardization, is that we actually do want to standardize certain things about running an OpenStack cloud and providing an OpenStack cloud or cloud environments, not just OpenStack, but we want to standardize that. But at the same time, we have to make sure that we do not dictate how CSPs actually build up their whole infrastructure, because that would hinder adoption in existing environments. So if we now basically look at how DNS is done, how NTP is done, and things like that, we may have to make sure that we promote best practices, that we make standards so that the customer can do certain assumption about SCS-compliant infrastructure, while at the same time making sure that an existing CSP does not have to fundamentally change the way they operate their whole infrastructure, because DNS and NTP is often things that are not solely done for just one cloud environment, but for the whole operations of that CSP. Oh.
Okay, great. Thanks for the answer. Are there any questions from the audience? Otherwise, I have a second question. Are there any other similar projects with other tools comparable to Yaook, or some similar projects that are also implementing these standards right now or building clouds that follow the standards?
Well, we do hope that there are certain other OpenStack-based clouds that will adopt these standards. So and that's actually not a secret. So I'm really trying to get Klura into the SCS group, because with Klura we have many good discussions, and also people from Klura were at last year's SCS summit and this year. So they are very open towards SCS, but they have not adopted these standards. And but they are also with people from Klura, we are working in the public cloud special interest group at Open Infra, which is another exchange point where we talk about how can CSPs make sure to have a better overall customer experience. That's also maybe I can do a bit quick advertisements there. So the public cloud, the special interest group, meets every 2 weeks, and it's basically we represent the CSPs towards the open infra development community, but also to external. So if you want to make sure that you as a CSP are being heard, please join the public cloud SIG. Josephine, for example, is part of the public cloud SIG, so I'm very happy that she's working with us there, and yeah.
And she also posted a question in the chat right now. So she says, how do you feel about adoption of standards which are currently only in draft? So no needed to be compliant right now.
How do I well, okay, so I have the luxury of not running a public cloud myself, so it's always easy to say that, but I think it would make sense for CSPs to actually adopt stuff that is in certain ways in a draft state, because it could also be a way to test drive certain standards. So we could basically, if a CSP has a region where they do testing stuff, they could adopt the standards there and basically provide valid feedback on whether it makes sense. Because as long as it's in draft state, it can still change. So I would not basically expose it to all the customers, but it would make sense to actually adopt them in certain environments to make sure to actually test drive stuff, because it's a good way to also see whether things go the wrong direction. Because that's and in the standardization effort, I think we can use more voices from the CSP community, and everyone who works in the SIG standardization knows that we actually have to make sure to get the CSPs always into the loop, and not just one of the CSPs, because the standards become better the more CSPs actually look at them and involve their operations teams also, because they have the knowledge on how to implement them and what it means.
Great, thanks. And maybe I have one last question from my side regarding Yaook. So after this project and this experience with setting up the SCS compliant cloud, how does this change Yaook? Is it like only a part of the documentation that now helps you to reproduce this process, or are there also some modifications in the software as such? Can you maybe explain a little bit more on that?
So there are, at this point with the level of standardization, we are at no modifications in the software needed. It's basically all in the either your configuration you supply Yaook with, or in what you do with Yaook once it's deployed.
Okay, great. So one last call for questions from the audience. Doesn't seem to be the case. Are there any questions? So then thank you very much once again for your presentation, Felix and Jonas. And now I will share again my slides to share some news and events from Alaska. So we have really great news this month. If you follow our website or our social media, then you will have already heard about this. But a huge milestone for Alaska and for one of the projects, specifically Krake, because we won the Sächsischer Digital Preis in the category open source. In 2024. So this is a prize that it's handed over by the State Ministry of Economic Affairs, Labor and Transport of Saxony. And this year it was focused on digital solutions that also help to save energy and raw materials and so on. So it was a great match for Krake, and yeah, we are very, very happy that we were nominated first, and then that we had a lot of support from the audience in general, from everyone who could vote, and we made it to the first position. So that's it's a great thing for Krake. You see here a picture of our colleagues Sarah and Marius collecting the prize, and yeah, it's a huge thing for Krake. So we're very happy about that, and thank you to all of you who maybe voted for Krake and supported it. That's the first thing that we wanted to share. Second thing is related to Yaook. So now we are listed in the Open Infra Universe, which is also very nice. The Open Infra Universe is a list of products that somehow either rely on local infrastructures or that help others to use them. So we're now listed here with Yaook. By the way, Sovereign Cloud Stack is also listed here very close to us. So also a very, very nice thing that we're very happy about. And regarding some events, well, we were present in June in a couple of events in Dresden at the Output DD event, which is organized by the Faculty of Informatics at the University of Dresden, and also the Silicon Saxony Day, which is an event related to different high-tech technologies, and there was a section on cloud transformation, and we were also there present with a presentation on Alaska. So we're continuing to inform the rest of the world about what we're working on, and networking and discussing with others their projects. Then we have the Alaska Summit, which we're working on, and we plan to publish the program today. So stay tuned for that. It will be available on the website. Just a brief reminder, it will be at the end of October in Dresden. And after the program is published, we will also publish in the next days a registration form so that you can start registering for the conference. Finally, just short information on the Tech Talks. We will have a summer break in July, so there won't be a Tech Talk in July, and then we will be back again in August on the 13th, again last Friday of the month, as always at 11. Are there any news or any events that any of you want to share with the rest of us? If so, just feel free to speak up. Okay, then just as always, brief reminder that you can find all the information on the Tech Talks on the website, that you can also subscribe to a mailing list, and then we will send you the invitations every month. And you can also always watch the past Tech Talks on YouTube. This one will also be uploaded in a few days. And then, so as I said, July, there's going to be a break. So the next time we meet will be in August 30th. We have a presentation by Matthias Hack from Uhuru-Tech, and he will be talking about his experience or their experience with installing and managing OpenStack installations that are diverse with Yaook and GitOps. So that will be the next time we see each other. Until then, I hope you have a really nice summer. Thank you very much once again to our speakers of today's Tech Talk. It was really, really a nice Tech Talk, and very, very good to have you here. And thank you to all the rest for joining. And as I said, have a nice summer, and see you in August. Goodbye.